Crimson Desert is a game that generally looks great and runs pretty well on a wide range of PC hardware, but it does have some rough edges with certain setting configurations which I'll try to optimize for you today. Noise, for example, is a particular problem that I've run into across my time playing the review build, and while it's not always noticeable, it can be distracting in certain scenes. A few optimizations that I'll run through in this video will help to minimize noise during gameplay. You also might simply be in the market for more performance. Crimson Desert is a slower paced single player title with a vast open world and beautiful scenery, but it does feel better to play at higher frame rates just based on the way the character moves and interacts with the world. I'll be exploring every setting in the game and how it affects both visuals and performance to give you a set of optimal settings that might be worth using. Few quick notes about test systems before getting into everything. All visual comparisons were captured at 4K using the NVIDIA GeForce RTX 5090 with DLAA enabled, except for examples of AMD specific features which were captured on the Radeon RX 9070 XT. I would strongly recommend watching this video using YouTube's 4K mode for the highest bitrate. Performance testing was performed primarily on an RTX 5060 Ti 16GB at native 1440p. The CPU used is the Ryzen 7 9800X3D with 32GB of DDR5 6000 memory.
Today's video is brought to you by Insta360 and their Link to 4K webcam, now available in white. Building on the original Link, the Link 2 includes AI tracking for individuals and groups, auto framing, and auto gesture controls. For a webcam, it has fantastic autofocus with no focus pulsing, which is a major plus. It also now offers modes such as customizable backgrounds, adding versatility to every use case. The Link 2 is equipped with a gimbal, making it perfect for presentations, meetings, group calls, and any situation where you might be moving around. The 4K 30fps sensor offers excellent performance even in low light situations, and you can really only get better performance out of something like a digital SLR camera. With various AI features and a user-friendly desktop app, achieving the perfect presentation's a breeze. It also pairs perfectly with the new Wave speakerphone. For more information on how you can score a discount plus an Insight Pro membership, please click the link in the video description.
So firstly, let's talk about some of the visual issues that crop up in Crimson Desert and how to mitigate them. I don't want this section to come across as being too critical of the game's visuals because on the whole I think it's a great looking title, but some of these rough edges do sort of expose the optimization and cutbacks that have taken place to improve performance. I should note here that the following sections are based on the review build of the game from March 13. I don't know if any of these problems will also be present in the launch version today, but I'm putting this section here just in case any of these problems crop up while you're playing. Noise is the primary visual artifact in Crimson Desert. Most of the time this isn't a problem, especially in outdoor scenes that are well lit, but across many of the game's indoor environments, I've found quite a few artifacts related to a low sample count for the game's lighting system. In this example, I'm running the cinematic preset with DLSS 4.0 quality mode enabled at 4K. You'll notice some blockiness, boiling, and other problems with the global illumination at the end of this sewer area. In this example, again cinematic preset but with DLSS 4.0 performance mode, entering the building shows quite a lot of low sample noise as the lighting transitions from outdoors to indoors, which resolves slowly over time. But even when exiting the building, you can see other noise artifacts. Here's another example, entering an underground area at night with the lantern on, cinematic preset with DLAA. There's a definite blockiness to the image quality and noise in the shadows. You'll spot similar on these curtains in this bank area. Again here with these stairs, lighting disocclusion is quite grainy and noisy, pretty ugly in my opinion. The common factor throughout all of these examples is the scene is indoors and globally illuminated. There's a few ways to mitigate this and make the problem less visible. Now you might be tempted to increase the lighting setting up to max, which is the highest level, but this actually makes the noise worse in some areas. If you're seeing shadow flicker, similar to what I'm showing in this environment, the solution is to reduce the lighting setting down to cinematic or ultra. Below ultra, noise starts to increase again, so I would recommend cinematic or ultra. I also found that using DLSS 4.0 instead of either DLSS 4.5 mode, the game allows you to natively choose between preset M and preset L, is essential for mitigating noise. For whatever reason, this game is less noisy when using DLSS 4.0. I suspect that there are issues with the DLSS 4.5 implementation in this title that will be worked on through patches, so this section may not apply in the future, but I don't know that for sure, so this is based on my experience with the title as is. Turning ray tracing off can help to mitigate some noise artifacts, but it also introduces other artifacts, so it's not a real solution to this problem. I also found some scenes where shadow noise is similar whether you have ray tracing on or off. It's just ray tracing off tends to produce different shadows while also struggling with other artifacts like disocclusion noise and reflection noise. The other issue you have to be aware of when using upscaling is that the sample count for lighting is set relative to the render resolution of the game, not the output resolution. This means that some lighting effects become lower quality when upscaled and more prone to noise. In this example, shadow detail gets blurrier when we use DLSS performance or even quality mode relative to DLAA, and there's more noise around some items, even though we're stationary. This isn't a typical DLSS artifact that we see in other games. This appears to be related to changes in the way the game renders at different resolutions. What this means is that running Crimson Desert at native resolution, or higher upscaling modes, is more beneficial than usual. In lots of games, you can get very close to native quality by using something like DLSS 4.0 balanced at 4K, with losses in temporal stability and detail in some areas. But in Crimson Desert, you're also sacrificing lighting quality. For this reason, I recommend playing at the highest render resolution where possible on your hardware. So to quickly recap, the best way to reduce noise artifacts involves setting lighting quality to either cinematic or ultra, specifically using DLSS 4.0 instead of DLSS 4.5, FSR4 is good on AMD GPUs as well, not disabling ray tracing, and then running at the highest possible render resolution, ideally native. The good news is that using DLSS 4.0 DLAA isn't too ridiculous in this game, as native performance is decent on modern GPUs. Upscaling when using cinematic settings isn't always a requirement in this title. This particular configuration doesn't fully resolve noise issues in indoor scenes. You're still going to see lighting artifacts until Pearl Abyss roll out patches to resolve these problems if they are able to. And I should once again reiterate that these problems are largely isolated to some indoor environments. Noise is not usually problematic in outdoor areas, and I did find quite a few indoor areas as well where noise is minimal. It's an ambitious game with lots of areas to explore, so not everything is visually perfect. The other option for reducing noise is to use NVIDIA's ray reconstruction or AMD's ray regeneration feature. However, enabling this setting is extremely taxing, at least in the build of the game I played. When you enable either of these AI-based denoisers, the game forces lighting quality to max, which itself is much slower to run than cinematic lighting. But then on top of that, it appears to further increase graphic settings beyond the maximum level, allowing for a higher quality image at the cost of performance. I say this because in some scenes you can see additional shadows being cast that weren't there before, as well as noticeable geometry changes from only enabling this one setting. It kind of makes ray reconstruction / regeneration a secret extreme mode for gamers, on top of the benefits from the actual denoising these features provide. Ray reconstruction significantly improves image quality and reduces the lighting noise in most scenes. Shadows become more accurate and less aliased, there's much less pixelation and grain across the image, and most importantly, noise is massively reduced. When combined with better shadows and global illumination that this mode appears to offer, enabling ray reconstruction is the ultimate way to play. AMD's ray regeneration is not as good as ray reconstruction and generally has more noise, especially when combined with the levels of upscaling required to actually use this feature. However, the amount of noise is typically reduced compared to running the game without ray regeneration, though not always, and you benefit from the above maximum quality settings that are enabled along with the AI denoiser. Based on this game though, AMD still has a long way to go to offer a feature on the level of ray reconstruction. The combined denoiser plus upscaling solution from NVIDIA delivers clearly the best image quality in Crimson Desert. That said, ray regeneration does provide some benefits to image quality for AMD users, so it's still worth exploring. That's not to say that ray reconstruction is flawless. Boiling is a problem when this feature is enabled, especially at lower render and output resolutions. This artifact is less noticeable than the noise it replaces, so it's a net win, but unfortunately there is no noiseless version of Crimson Desert in these interior locations. The other issue is that ray reconstruction deletes rain from the game. In this example, I'm comparing ray reconstruction on to the game's cinematic preset, both with DLSS performance enabled. Rain is clearly visible in this scene without ray reconstruction enabled, but after you enable it, rain is seemingly treated as noise and is removed. You can even see the rain effect fade away over time immediately after enabling ray reconstruction. And this problem persists at the highest quality the game offers, 4K with DLAA. This is an area that will need to be fixed because it's pretty weird playing the game while it's audibly but not visibly raining. and it's a significant trade-off for using the best denoiser. Unfortunately, I wasn't able to capture rain footage with ray regeneration to see whether this is also a problem for AMD's solution. In terms of performance, enabling either ray reconstruction or ray regeneration is extremely taxing. On the RTX 5060 Ti 16GB, I ended up with just 1/3 the performance of the cinematic preset after enabling ray reconstruction, with half of that drop attributable to changing lighting to max. I saw a similar impact on the RX 9060 XT 16GB, with both techniques having a similar performance cost in my benchmark pass. What this means is that if you want to use AI denoising as a solution to Crimson Desert's noise, you have to use significant upscaling to counteract the performance loss. I found that Ray Reconstruction plus DLSS Performance Mode offers similar performance to the cinematic preset with Ray Reconstruction off and DLAA. In terms of noise and artifacts, I prefer the Ray Reconstruction plus DLSS solution, though of course there are trade-offs in other areas. It's also not ideal if your baseline was, say, DLSS quality without ray reconstruction. My suggestion here will actually cost you performance relative to that configuration. But if you are playing the game using native rendering and you are annoyed at the level of noise, I would suggest experimenting with the taxing ray reconstruction mode and enabling DLSS performance, so long as you have at least a 1440p display, because DLSS performance isn't always the best on those lower res displays. There's a couple of other issues in Crimson Desert to discuss. One relates to texture quality and overall blur. Earlier, I mentioned that the render resolution of the game impacts the sample count of lighting effects. Well, the render resolution of the game also seems to affect texture quality, with lower than native render resolutions looking quite blurry, even when using technologies like DLSS 4. In other titles, what we usually see is that the level of blur is pretty similar, whether we use native rendering like DLAA or lower modes like quality and performance, especially when standing still. With Crimson Desert, in the current build, the game gets noticeably blurrier when using upscaling. This blur looks quite weird though. It doesn't seem like the game is switching to lower quality textures. It seems more like a bug to me, so I expect this to be fixed quickly in post-launch patches. However, in the case that it's not fixed, the easy solution is to use native rendering, especially DLSS 4.0 DLAA, which looks the best in my opinion. Lastly, I should mention pop-in. There's quite a bit of pop-in playing Crimson Desert, especially when moving fast on your horse or flying around. Draw distances can be very impressive in some scenes, with beautiful vistas and tree details extending far towards the horizon, but the pop-in issue is related to how the game loads in objects closer to your character for extra detail and density. This draw distance for high quality elements is quite close to the character, and pop-in is harsh even on the highest visual quality settings, meaning high detail elements often appear suddenly out of nowhere, and lighting effects like shadows can visibly improve as you're moving, with an obvious line separating the high and low quality effects. This is just how the game works, and seems a side effect of the developer's optimization to make the game run well and use a lower amount of VRAM. There is no setting in the game that allows you to extend this close draw distance barrier to minimize pop-in, which is unfortunate as you do see a bit of it on the highest quality settings. While I have spent a lot of this video so far talking about the issues with Crimson Desert's PC graphics, I want to stress that overall I think the game looks great and it runs well. The idea here is to explore some of the drawbacks to the visuals and how PC gamers can mitigate these problems to get the best experience. This is absolutely not a Borderlands 4 situation where the game runs terribly to begin with and needs major setting tweaks to become playable, and I think a lot of what I've talked about here will be fixable through patches. What it also shows is that optimization is a hard task, and it's very difficult to make a game that has flawless visuals and runs magnificently. I'd describe Crimson Desert's visuals as rough around the edges. The optimization compromises they've had to make are not exactly hidden, but they also don't crop up often enough to be a major issue. This is a really ambitious game in its scale and gameplay system, so the fact that it all comes together with this level of visuals in an open world without major performance issues is quite amazing. Now let's move into talking about the settings in the game. I'm going to start with the settings that have little performance impact in the areas that I've tested, and I should note here that I've used a couple of different benchmark runs to evaluate performance. We've got an outdoor daytime scene, an outdoor nighttime scene, and an indoor scene. As it turns out, most settings offer similar scaling regardless of these conditions, except nighttime scenes tend to run a bit worse than daytime scenes, but otherwise the scaling is the same. Texture quality, no performance impact, and most settings offer the same visual quality. If you drop to low textures, overall texture quality is reduced and some detailed textures are removed, which saves about half a gigabyte of VRAM in most scenes that I looked at. You should keep this on cinematic. Effect quality claims to affect things like flames and smoke, so naturally I went and looked for that in the game's world. I didn't spot much difference between cinematic and low settings and saw no performance impact either. I could be missing something, but for now I'd leave this on cinematic. I didn't see any performance impact changing the simulation quality setting and couldn't find any obvious visual differences either. The game has a range of physics simulations such as object collisions, cloth simulations, ropes and more, but this setting didn't seem to make much of a difference to any of them, so may as well keep it on cinematic. Post-process effect quality is another setting which seems to have minimal impact. I found that if you turn the setting to low, it disables lens flares, but outside of that, I didn't spot much change. Turning this setting from cinematic to low improved performance by 1%, which is margin of error type stuff and not worth messing with. Another setting with surprisingly low impact is water quality. Even when I was swimming around in a huge body of water, the difference in frame rate between cinematic and low was negligible. Visually, water quality doesn't make a huge difference to the surface quality of the water, reflections and so on are dictated by other settings. However, if you turn this setting down to medium, some surface interactions are removed, and then on low, you no longer see any ripples or interactivity as you swim around. I'd recommend keeping this on cinematic, given the lack of performance cost, and this will give you the highest quality water simulation, which in this game can look pretty good. I also want to touch on here again the ray tracing setting. This option does create a noticeable visual difference. Turning it off leads to much worse and less accurate reflection quality, reduced shadow accuracy, and different global illumination that typically looks less realistic. What I found surprising is that turning off ray tracing does not improve performance. In fact, in some situations, disabling ray tracing actually made performance worse by 1 or 2 frames per second. This setting is left enabled for most presets, only switching off for the low preset, I presume for compatibility with older GPUs that are bad at ray tracing. To me, it seems like this game engine is designed with ray tracing in mind, so the fallback rasterization only mode is not especially well optimized to boost performance. This means the best way to play is leaving ray tracing enabled on most hardware, even if you're in search of performance. It's a rare example of ray tracing looking and performing better at the same time. Now let's take a look at the settings with a mild performance impact. Shadow quality controls the resolution of both near and far shadows. There's a distinct draw distance line between these shadow types in motion, which is unchanged between the highest and lowest settings, so you can't get high quality shadows further into the distance with higher modes. However, lowering this setting affects the resolution of both types of shadows, so once you hit medium and low, all shadows become blurrier and have a tendency to flicker. There also doesn't appear to be a huge difference between the highest modes. Performance-wise, I saw a 2% improvement dropping this setting from cinematic to ultra, but no further improvement from the lower modes. These other modes might give larger gains on very constrained hardware, but I think for most people, ultra is the optimal choice here. Reflection quality affects how many surfaces display reflections, as well as the quality of these reflections. In this river example, you'll see that the riverbank is more reflective with better material quality using cinematic or ultra, with cinematic having better draw distance. High and medium remove these additional reflections, while low also cuts back on reflection resolution. However, so long as you're using medium or higher, reflection resolution is largely the same, as seen throughout this puddle example. This setting does not have a huge impact on performance, so I would recommend keeping it on cinematic. Moving to low can improve performance by 2%, but given reflection quality is significantly reduced, that isn't worth doing. Foliage density is a very simple setting. It controls how many shrubs and grasses are shown on screen. A higher setting means more foliage at greater distances. I typically found it quite difficult to spot the difference between cinematic and ultra, while there is a small downgrade to high, particularly for far grasses. Medium is another small cutback, then low substantially strips back foliage density, so I'd only recommend that configuration for low-spec gamers. The performance data shows that foliage density only really starts to have an impact when dropping to medium, where you'll gain 3% to performance and then 4% for low. I'd recommend keeping this on cinematic or medium if you're desperate for more FPS. Volumetric fog quality has a subtle impact on image quality. This is not a game where dropping volumetric significantly boosts performance, rather even the high settings have tame quality in this area. I noticed small improvements to fog draw distance and quality when using higher settings, with a particular fall off when using medium and low. Indoor fog, for example, has many more artifacts when using low compared to high, and this is despite a negligible performance impact in this specific interior scene. Overall performance can be improved by 2% using high settings, and there's no further gains to be made. Cinematic does appear to offer slightly better quality, but given how small the differences are in my opinion, high makes the most sense for this setting. There's also a setting called Advanced Weather Effect, but I found this effect difficult to test, so I've omitted it here. One of the more intensive effects in the game is model quality, which affects the geometry throughout the game. It doesn't have a huge performance impact, but certainly more than the other settings. What's interesting about this setting is that lowering this doesn't always make the game look obviously worse. It's clearly changing aspects to geometry. Some surfaces become bumpier, others become a different shape, but when you compare cinematic to high or even medium, it's not clear to me which is subjectively worse looking. I think the middle and lower settings look just fine. The biggest changes between each mode are that Cinematic adds more tree branch and leaf detail compared to Ultra, so the overall game world looks more dense when using the higher setting, and that could be a reason to keep using that mode. Another large change is between medium and low, where low typically offers the most simple object geometry and a much flatter ground. Performance-wise, this also plays out in the benchmark results. Switching down to Ultra boosts performance by around 4%, and you get a 9% boost moving to low, but there isn't much difference between Ultra, High, and Medium. I do think Cinematic looks best, so I guess this setting is well optimized, but outside of that, I'd recommend Ultra for most people. The visual difference relative to Ultra isn't that noticeable during most gameplay, and it is a good way to recover some performance. The most performance-intensive setting in the game, outside of ray reconstruction/regeneration that I looked at earlier, is lighting quality. This setting can substantially affect how the game looks, and affects multiple areas to visual quality. Global illumination is one such area. Higher lighting quality settings have better, more accurate global illumination, with more surfaces affected by indirect light sources and bounce lighting. In this area, there are only minor differences between Cinematic, Ultra, and High, but once you get to Medium and especially Low, a lot of this global illumination is stripped away, so indoor lighting on the low setting can look very different and much worse than the high settings. Typically, the medium and low settings, both indoors and at night, look a lot darker, with the higher settings having more natural lighting. In addition to this, the resolution of global illumination appears to be affected when turning down the setting. This tends to make high look a bit rougher than Cinematic or Ultra. But then there are bugs like the issues I showed earlier with the max settings, despite improvements in other areas. The other thing lighting quality changes is reflection resolution, even though there's a separate reflection setting. Max, for example, has noticeably higher reflection quality and resolution compared to Cinematic, at a large performance cost. The surface of water looks a bit muddy on Cinematic, but much improved on Max. However, there is little difference between Cinematic and High in this area. Medium then appears to remove ray traced reflections, replacing them with a much simpler presentation that is more akin to the ray tracing off mode. From a performance standpoint, there is a large improvement in FPS moving from Cinematic to Ultra. The game runs 9 to 10% faster both during the day and at night. But then Ultra, High, and Medium all offer similar performance, so you may as well use Ultra given it does look better and has fewer artifacts. Low improves performance by around 14% compared to Cinematic, but clearly looks the worst, so I'd only use that mode for lower spec hardware. There's also the enigma here of the max settings. This mode does offer much higher resolution lighting effects at the cost of some artifacting, but it will also reduce performance by over 30% compared to Cinematic. This makes it hard to recommend unless you're going all the way and using ray reconstruction, which enables max lighting anyway. There's a couple of other small tidbits to mention. Crimson Desert does have a setting to adjust motion blur and particle effects, but they are in the accessibility section, not the main graphics section. So if you want to adjust those settings, or for example remove motion blur, that's where you'll find them. Neither has a substantial performance impact. The game also offers a preset below low called minimum, which is the only time the minimum settings are exposed. This mode substantially strips back visual quality, especially environment density and model quality. It also flickers a lot more than even low settings, so it's clearly designed for the slowest hardware. On an RTX 5060 Ti, this preset runs about 15% faster than low. For most people, I just wouldn't recommend using it. Here's my recommended settings for Crimson Desert. Most of these options are quite well optimized to begin with and don't substantially reduce image quality or performance unless you drop them to medium or low. This means most gamers can safely use the cinematic settings for the most part. There is a couple of settings I'd reduce to improve performance, and those only have a minor cost of visual quality. Currently, I'd recommend pairing these settings with native rendering, though upscaling could become more viable in the future if Pearl Abyss address some bugs. Luckily, even though we haven't changed too many settings and don't recommend extensive upscaling, the game runs well on a lot of hardware, so optimization is less necessary in this title. For those with high-end systems, I'd recommend enabling ray reconstruction along with upscaling for the best image quality. The ultimate experience would be pairing this with native rendering like DLAA. However, this is extremely taxing even on an RTX 5090. It only achieves around 30 FPS at 4K with this sort of configuration. But on a positive note, that means there's a lot of scaling here. The cinematic/ultra settings run quite well on modest hardware, but you can really crank things up if you've got a high-end GPU. In terms of performance, our optimized settings offer slightly better performance than the Ultra preset, coming in around 18% faster than the highest cinematic preset. That's a pretty good result and is preferable to even high or medium, considering both of those presets are quite close in performance. Of course, we're not seeing anything crazy from our optimized settings here, because Crimson Desert on the whole is already pretty well optimized, so those choosing to use the cinematic or Ultra presets will get a good experience. But it's always nice to know what options you can crank back up and which settings make the most performance difference so you can optimize and tweak things for yourself. For example, if you need to use low settings to get acceptable performance on your hardware, you can probably raise things like texture quality and shadow quality to gain a good amount of visual quality at a negligible hit to performance. There's not a whole lot more to say about Crimson Desert on PC. This is a game that can look great and run really well, but it's also rough around the edges, so careful selection of settings is necessary for the best experience. There's a few visual issues I noticed that Pearl Abyss will need to patch, so I'll be looking for that in the weeks after launch, especially to address the blur when upscaling. When you don't run into some of these visual issues, Crimson Desert is a really stunning game with some insane environments to explore. The game is also massive in scope from what I've played. This testing is largely focused on the early areas you'll find in the game to avoid spoilers, but there is so much more. I've barely visited any of the map. I'm really enjoying what I've played so far. There's a sense of wonder when exploring that's really inviting, and a lot of the mechanics are quite fun. I haven't gotten anywhere near far enough into the game to talk about the story because it doesn't reveal much in the early hours, which is actually something that I like, so look for actual game reviews to see how that goes. Anyway, that's enough. Hopefully you found these optimized settings and tips for Crimson Desert useful, and if you do want to support Hardware Unboxed and the independent testing that we do, we have our Patreon page. Links to that is in the description below. If you sign up, you get access to some pretty cool benefits. Get our Discord community if you want to chat about this. We've also got monthly live streams, BTS content, and plenty of other good stuff. So thanks for watching, and I'll catch you in the next one.